Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math, Grade 8, Unit 1, Lesson 6. Okay, our first question here. Here is trapezoid A on a coordinate plane. Draw polygon B, the image of A, using the y-axis as the line of reflection. So this is our y-axis. So we need to reflect this figure over the y-axis, which we'll put it here. Straight across the same number of units. That's 2 units. That's 2 units. 4 units. 4 units. 2 units. 2 units. 4 units. 4 units. And it says to call that polygon B. Okay, next it asks for polygon C, the image of B. So the image of B using the x-axis as the line of reflection. So we want to reflect this figure over the x-axis. So 1 unit down, 1 unit, 1 unit, 3 units, 3 units, 4 units, 4 units. So that is polygon C. Now, polygon D is the image of C using the x-axis as the line of reflection. Well, where's the x-axis? It's this line right here. How many people look at this problem, see to do it again, and imagine it's going to wind up somewhere in this quadrant? Well, this time it's not. If we reflect C over this axis, this point here will go 1 unit away, so 1 unit up here. 1 unit away, 1 unit up here, 4 units away, 4 units away, 3 units away, 3 units away. Hey, look, this spot right here isn't just figure B. This is also figure D. Both of those match right there. Okay, our next question here. The point -4, 1 is rotated 180 degrees counterclockwise using center of -3, 0. What are the coordinates of the image? So, a rotation like this might be easier to visualize if we had a coordinate plane, I think. Well, then isn't it lucky that we have one right now? Okay, for our... Whoops. There we go. Well, then isn't it lucky that our coordinate grid here, we need the point -4, 1. -4, 1 is right here. We want to rotate 180 degrees using the center -3, 0. -3, 0. So, if that line connects our point to our center of rotation, rotating it 180 degrees... 180 degrees makes a straight line in the same distance. This is where our new point needs to be. What is that point? That is the point -2, -1. So it looks like our answer is C. Okay, next we have to describe a sequence of transformations for which triangle B is the image of triangle A. So we want B to be the image of triangle A. So what do we have to do to A to turn it into B? Well, the first thing I notice here is these are oriented differently, which means we're going to need a reflection. Let's reflect over the y-axis. So first, reflect it over the y-axis. That puts that 1 unit. That puts us here. Well, they're touching, but that doesn't quite help. If we're going to put this vertex here, we need to go up 2 and right 2. If we want to put this vertex here, we have to go up 2 and right 2. So step 1, we reflect it over the y-axis. Step 2 has to be translate up 2 and right 2. So we translated up 2 units, right 2 units, up 2 units, right 2 units. Now figure B is the image of figure A. Next question here says, here is quadrilateral ABCD. Draw the image of ABCD after each transformation. So there's our quadrilateral. If we want to translate point B to point D, well, here's B and here's D. Translate point B to point D would look like that. A reflection over segment BC. Well, the easiest part of that is this segment right here stays right where it is. A has to go perpendicular to the line of reflection, the same distance away, and D has to go perpendicular to the line of reflection, the same distance away. So you should get a figure that looks like that. Rotation about point A. So we're rotating about A by angle DAB, counterclockwise. Make this one a new color. So there's our figure. We want to rotate around point A by angle DAB, which is this much. This would be much easier if it let me rotate around a specific point. But there you go. That is a counterclockwise rotation. We rotated this part to here, which means we rotated this angle, angle DAB. Is our last question right? Yep. This has been another episode of Mr. Boskin Does Some Math. Thanks for tuning in. See you next time.